Hello class. So I'm sure you're looking at this fraction and saying, what on earth is that? That thing looks incredibly complicated. And you're right, it does look incredibly complicated, and that's why it's called a complex fraction. And it actually simplifies the same way any fraction simplifies. Now, while we don't know how to divide the difference of two fractions and the sum of two fractions, we do know how to divide two fractions. So we can actually write this numerator as one fraction by creating a common denominator, and we can do the same thing for the denominator. So let's do that. Alright, I want these things to have the same denominator. So this needs to have a multiple of 4 and x, so let's just multiply the numerator and denominator by x of this fraction, and this one will multiply the numerator and denominator by 4. And now we get x squared minus 4 over, here I'm skipping steps, let's not do that. X squared minus 4 over 4x, and 4 over 4x. And because they have a common denominator, we can rewrite them as x squared minus 4 all over 4x. And I'm sure your question is, why am I putting parentheses around the numerator and denominator? Like we discussed in the addition and subtraction of fractions video, the biggest mistakes that occur are when you don't realize you're actually subtracting the entire numerators. So just to play it safe and to be consistent with what I said, I'll write it that way. And noting that there's only one term here, this will become x squared minus 4 over 4x. Alright, so that's only the top half. This is looking a little bit more friendly now. Let's look at the bottom half. Alright, these will be the same if they are also 4x, so we need to multiply this fraction here by x in the numerator and denominator, and this fraction by 2. And we'll get 2 over 4x minus, plus x over 4x. That'll become 2 plus x over 4x, which is equal to 2 plus x over 4x. Matter of fact, let's make that fraction bar all along here red. Okay, so now we have something else that looks kind of monstrous and crazy. Let's copy it. Can I get the bottom here? Ooh, that didn't copy right. Alright, so we're going to rewrite that so we can use it. Now, I don't know how to divide fractions in this format, so I'm going to write them the way I'm used to writing them, which is like this. I have x squared minus 4 over 4x divided by 2 plus x over x. Now this is something we were just, 4x. This is something we were just doing the other day. The first thing you have to do, of course, is to change this to a multiplication problem by the reciprocal. So let's do that now. This becomes multiplication. The first fraction is the same. X squared minus 4 over 4x. And this one will flip over. Okay. Now we want to factor as much as possible. This numerator here is a difference of squares, so we'll factor that. That's x plus 2 and x minus 2 all over 4x times 4x over 2 plus x, which is the same thing as x plus 2. Now, if this was 2 minus x, these are actually would not be the same. Their cancellation would actually leave a negative 1 rather than a 1. But in this case, it's just a 1. So this will cancel, goes into itself once, and it goes into here once, leaving a 1. 4x and 4x obviously divide into each other evenly once, leaving us with a numerator of x minus 2. So the answer to this problem is x minus 2, where x is not equal to what values? Looking here, which is where we always check, at the multiplication part before all the cancellations occur, we want to see what values would make this undefined, and those values that make this undefined are when x is equal to 0 in this fraction, x is not equal to 0 here, and x cannot be equal to negative 2 here. Alright? If either of those are true, then this expression should not work for those values. So our final answer is x is not equal to 0 and negative 2. Oh wait, not negative 2. Yeah, negative 2. Okay. So that's our final answer. If we go back to the beginning, let's just take a quick peek at how complex this fraction looks and how simple the answer winds up being, the simplified expression. Alright, and again, the reason for simplifying expressions is, while things like this occur in real life, we don't normally want to work with those. By simplifying, we get something simpler we can use. Perhaps this would be talking about some real-life problem where this is money over 4 divided by something over the amount of people you have, and all these other crazy variables. And then we simplify it to simply knowing that it's the amount of money minus 2. Something easy to work with. So yeah, that's the end of that. We'll probably go over one example in class, just because this is a bit confusing. It's nice to have this video, I think, to walk you through an entire example. There's another way we can look at this, so let's actually do that real fast. I'm going to erase parts of this. I'm going to erase everything up to here, I think. I'm going to leave that. Because now that you know this is, again, division, you might want to just skip some steps and make your life a little easier. The denominator of your denominator goes to your numerator. Again, this is divide by this, so it's the same thing as saying multiply by here and multiply by that. Alright, so if you have a fraction in your denominator, you can just bring it up to the numerator and flip it over, which is the same thing as saying multiply by the reciprocal. So this brings us back to where we were before. So if I had to label some steps here to make this easier on yourself, I'd say create 2 fractions. Make a single fraction out of the numerator, a single fraction out of the denominator. Change that to multiplication by the reciprocal. So x squared minus 4 over 4x times the reciprocal, which is 4x times 2 plus x, and then simplify. Well, factor x minus 2, x minus 4, x plus 4, x plus 2. So this is kind of like the quick looking version here. So first things first, write them as 2 fractions, one in the numerator and one in the denominator. Change it to multiplication by the reciprocal, and factor, identify the excluded values, then simplify. Okay, I'm not going to write them on the screen. You can replay that segment real fast. I'll even run it through myself once more. Write the numerator as a single fraction. Write the denominator as a single fraction. convert that into multiplication of fractions by multiplying by the reciprocal, factor, identify the excluded values by looking at the factored form of the denominator, simplify. And that's it. Much easier than it looks. Does look complicated though. Now I paused the video and I added another example, so let's look at that real fast just to make sure everyone's clear. This came directly out of the Regents exam, the New York State Regents exam. So let's start off by making our numerators the same. So this is really the same fraction as a over 1 and d over 1. So to get a common denominator of c, we're going to multiply the numerator of just this fraction by c. And the numerator, the numerator and denominator of this fraction also by c. So here is our new fractions. We've got CA, or AC, plus B over C, their common denominator. We have CD minus B over C, their common denominator. This is the same thing as saying CA plus B over C times C over CD, CD minus B. And now we can cancel out some common factors. These don't have any common factors, but these C's are common. So just canceling those out. Okay, so that leaves us with the fraction, I'm going to write it as AC plus B over CD minus B. Okay, and that should be it. Actually, looking back here, what values can all of these variables not take on? According to this, C cannot be equal to 0, or this fraction will be 0. In this case, B is not equal to CD. Okay, and CD cannot be equal to B. Any of those things occur, then the fraction will be undefined. So I suppose this would be our final answer to put this together. Okay, hopefully that makes sense. Have a nice day.